Okay, so today we're talking about quadratic formula, and why we just did simplifying square roots was because the quadratic formula has a square root in it. So let's first do some review, right? Square root of 4 is a perfect square, so that would just become 2. Square root of 4 is physically 2. For letter B here, we would have square root 25. 25 is another perfect square, so the square root of that would be 5. For 29, square root of 29, what this one is, this is not a perfect square, but in order to figure out if a perfect square goes into it, and you're just not sure if one does or not, it's best to just start dividing 29 by the perfect square. So like, take 29 and see if you can break it up into radical 4 and something else. In this case, you divide 29 by 4, it doesn't work, right? It doesn't give you a whole number. So then you try the next perfect square, which would be 9, because that's 3 times 3. 29 divided by 9, again, does not work, so we're not going to go 9 either. So then we go, what's after 9? 4 times 4 is 16, so you take 29, you divide it by 16. Again, would not divide evenly. So then after 16, we have 5 times 5, which is 25. And then 29 divided by 25, again, would not give us something even. So there's no perfect squares that we can take out of this square root of 29, so we literally just keep it as the square root of 29. Lastly, letter B here, we can pull out a perfect square out of this, right? It's the square root of 4. 8 divided by 4 gives us the square root of 2. Square root of 4 becomes 2, so then this radical becomes 2 radical 2. All right. So let's simplify the following. This is x equals negative 3 plus or minus square root of, and then this is 3 squared. So when we're simplifying this, we can't do anything with the negative 3. That symbol that I said is the plus or minus symbol is also going to stay. We can simplify 3 squared, that becomes 9. We can also simplify this negative 4 times 1 times negative 1. If I'm typing this into my calculator, I'm literally typing negative 4, multiply sign 1, multiply sign negative 1. When you multiply all of those together, negative 4 times 1 would give us negative 4. Negative 4 times negative 1 gives us positive 4. So we put plus 4. And then the bottom, 2 times 1, that's going to just become 2. So from here we can simplify a little further. That negative 3 still staying there, plus or minus also still staying there. 9 plus 4 actually becomes 13, and that's all divided by 2. At this point, if you could simplify the radical, you would need to do that, all right? But in this case, 13, the only numbers we need to see if it's divisible by are 4 or 9. And neither 4 nor 9 evenly divide 13. So we can't pull a perfect square out of 13. So in this case, I like leaving it exact, which this is an exact simplification. If I asked you for the decimal, you would need to type in 2 separate things because there are 2 numbers here. The first one is negative 3 plus the square root of 13 over 2. The second number is negative 3 minus the square root of 13 over 2. So that's how you would simplify that big old scary thing with a square root. Let's try out letter B. Letter B here, we're going to go 4 plus or minus, and then this is the square root of. We can simplify negative 4 squared. That's negative 4 multiplied by negative 4, which gives us 16. So that's 16. We can multiply negative 4, 1, and 3. That's negative 4 times 1 times 3, which gives us negative 12. And the bottom, we just have 2 times 1, so it's 2 times, or it's just 2 down there in the bottom, because 2 times 1 is just 2. So let's simplify this. So we have 4 plus or minus 16 minus 12 gives us the square root of 4, all of that divided by 2. Which that actually simplifies even further to become 4 plus or minus square root of 4 is 2, all of that divided by 2. If the square root disappears, we need to break it into its 2 separate signs. And we know it's always 2 separate things because of that plus or minus. So it's 4 plus 2 over 2, and it's 4 minus 2 over 2. 4 plus 2 over 2 becomes 6 over 2, which gives us 3. And on this other side, 4 minus 2 becomes 2 over 2, which gives us 1. So when you simplify this, you get out two numbers. Just like in the last one, we also got out two numbers. They're just decimals. All right. So let's take a look at letter C here. Letter C, when we're simplifying it, we have negative 7 plus or minus the square root of 7 squared is 49. Negative 4 times 2 times 3, that's going to be negative 8 multiplied by 3 more is negative 24. All over 2 times 2, which is just 4. So then if we continue, it's negative 7 plus or minus the square root of 49 minus 24 gives us 25 over 4. Square root of 25 is a number, so we go negative 7 plus or minus 5 over 4. And then we can split it into its two cases again. That's negative 7 plus 5 over 4, and negative 7 minus 5 all over 4. Negative 7 plus 5 is negative 2 divided by 4, so negative 2 over 4 would be negative 1/2. On the other side here, we have negative 7 minus 5, which would give us negative 12 over 4. Negative 12 divided by 4 is negative 3. So there's our two numbers. All right. And whenever you have a plus or minus like this, it's always going to be two numbers. So make sure you get two numbers out of there. So next question here, what is the standard form of a quadratic? Well, if you don't remember, it's y equals ax squared plus bx plus c. So why is that important for today? The quadratic formula, which is what we're about to write down, actually comes from standard form quadratics. And so when we use the quadratic formula, what we're finding is the x values for a quadratic that is set equal to 0. All right? And we're going to go into more discussion about this pretty soon here. So what is the quadratic formula? The quadratic formula is really long and intimidating, but don't worry. There's some songs you can listen to for you to memorize the quadratic formula. So it starts like this: negative b, and then plus or minus a big square root, and then we say b squared minus 4 times a times c, and then that entire thing that we just wrote in the top is getting divided by 2 times a. So extremely intimidating, right? But this is the quadratic formula. It's something you have to memorize. You're going to use it a bunch in the rest of this class. You're going to use it a bunch more in Algebra 2 when you get there someday. So it's something that you're going to have to memorize. The most popular song that goes with memorizing this formula is Pop Goes the Weasel. All right, and I promise, memorizing a song for this is going to be the easiest way to memorize this formula. I still sing this song when I'm trying to figure out the quadratic formula sometimes. I actually learned it to Jingle Bells, which I'll sing both. So, Pop Goes the Weasel. If you remember Elf, Elf is playing with those little crank toys, and they go, and then it pops out and it goes, wah! Okay, that's what that song is. So, Pop Goes the Weasel. Here it goes. It's negative b. Wait, now I'm forgetting it. So it's negative b plus or minus square root b squared minus 4ac all over 2a. So that's negative b plus or minus square root b squared minus 4ac all over 2a. All right, for Jingle Bells, it goes x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So that's x equals the opposite of b plus or minus square root b squared minus 4ac all over 2a. So those are the quadratic formula songs. My singing is horrible. If you want to listen to someone who's better than me, go to YouTube. I'm sure there's plenty of videos and probably different songs that you can use to memorize the quadratic formula. Anyway, let's do an example of actually using the quadratic formula to solve for x. So in order to do this, what you would do to start is you need to set a quadratic equation equal to 0. So in this case, we're just going to subtract the 5 to the other side. We're going to say x squared minus 3x minus 5 is equal to 0. And then we're going to use that quadratic formula. The a value in this case is 1, because there's a 1 out here. The b value is this negative 3. And then the c value is negative 5. So our formula goes x equals negative b, so negative 3, and then it's plus or minus the square root of b squared, so negative 3 squared, and then that's minus 4 multiplied by a, which is 1, multiplied by c, which is negative 5, and then that entire thing is getting divided by 2 times a. All right, and that's exactly how you would plug it in. So b gets used twice in the equation, a gets used twice in the equation, and c only gets used once. From here, you would need to do a lot of simplifying. So negative 3 makes positive 3, plus or minus the square root of. Negative 3 squared is 9. Negative 4 times 1 times negative 5 is positive 20. And then all of that is divided by 2, because 2 times 1 is just 2. So then you have 3 plus or minus the square root of 29, all divided by 2. And that would be your solution. For x, these are x values of that equation. These are specifically the x values that make this equation equal to 0. All right? So let's try a couple more examples here. I think it's always helpful to label your a, b, and c. So a is equal to negative 2. B is equal to 1, C is equal to 3. So this is x equals the opposite of b, or negative b, so negative 1 plus or minus square root of b squared, which is going to be 1 squared, minus 4 times a, which is negative 2, times c, which is positive 3. And then all of that is divided by 2 times a, which is 2 times negative 2. You're always going to have to simplify these. So negative 1 plus or minus the square root of 1 squared is going to become 1. Whoa, what just happened there? 1 squared is going to become 1. Negative 4 times negative 2 is positive 8. Positive 8 times 3 is 24, so plus 24. Over 2 times negative 2 is negative 4. We can simplify further to go negative 1 plus or minus the square root of 25 over negative 4. So that gives us negative 1 plus or minus 5 over 4. And now we have to split it into its two cases. Negative 1 plus 5 all divided by 4, and negative 1 minus 5 all divided by 4. Negative 1 plus 5 is going to become positive 4 over 4, which is just 1. Negative 1 minus 5 is going to be negative 6 over 4, which you can reduce to negative 3 halves. All right. So, letter B here. We have x squared minus 7x plus 10 equals negative 1. You first need to add the 1 over. In order to use the quadratic formula, the quadratic equation has to be equal to 0. So now that it's equal to 0, we have our a value, which is 1, our b value, which is negative 7, and our c value, which is 11. So then we need to plug it into the equation. X equals the opposite of b, so negative 7, plus or minus the square root of, we have b squared, so negative 7 squared, minus 4 times a, which is 1, times c, which is 11, and then that whole thing is getting divided by 2, multiplied by a, which is 1. So that is 7, positive 7, plus or minus the square root of. Negative 7 squared would be 49. And then that's minus 4 times 1 times 11, which is 44. And then all of that divided by 2. So this gives us 7 plus or minus the square root of 49 minus 44 is 5, divided by 2. And there is our solution. Okay? So, do we remember this? So this is an example from a while ago, right? And I just had us estimate these x-intercepts because it didn't cross at a perfect number. All right? So, where do these decimals come from then that says these x-intercepts? They come from the quadratic formula. So, big aha moment here. What we're finding when we use the quadratic formula is the x-intercepts. So the quadratic formula finds x-intercepts. And that should be the big takeaway from today, that the quadratic formula finds the x-intercepts. So let's try it with this equation. X equals the opposite of b, so negative negative 4, plus or minus the square root of b squared, which would be negative 4 squared, minus 4 times a, which is 1, times c, which is 2. All of that divided by 2 times a, which is 2 times 1. And then it's a lot of simplifying from here. So that's 4 plus or minus the square root of 16 minus 8 all over 2. And then we can do a little bit more. So that's 4 plus or minus square root 8 over 2. And at this point, if I'm asking for decimals, we can just plug it straight into Desmos here. And here's how we would plug it into Desmos. You need to do, in parentheses, 4 plus square root of 8. And then close the parentheses. And then that's divided by 2. So there's our 3.414, which is right here, okay? The other one is 4 minus the square root of 8. Whoops, forgot to put that in parentheses. And then divided by 2, which gives us 0.586, which then is this x-intercept. So, quadratic formula is used to find the x-intercept of a quadratic equation. Boom. All right. So that's the notes for today on the quadratic formula. If you have any questions, as always, message me on Canvas, guys.